Hello everyone and welcome back to this course on Introduction to Database Management Systems and SQL. So before we get started, just a reminder that this course is being brought to you by the Launchpad initiative by Newton School. The link to Newton School website is going to be given in the description, so please do remember to check that out. So you can follow the video series in YouTube, or you can register for the course from Newton School site as well. It's going to be a free course. So if you come to the Newton School website and sign in, under the Launchpad tracks, search for the course like Introduction to Database Management System and SQL by Pratik Bhattacharya. You can apply for the course here. So the added advantage of applying for the course from Newton School site is that along with the videos, you will also be able to participate in the quizzes. You will be getting assignments so that you can keep track of your courses. There will also be doubt clearance session. And after the course is over, there will be a certificate as well. So that's the advantage that you get if you are registered to the course from the Newton School site. Now we will carry on and we'll go ahead with the course. So till yesterday, we were discussing about modeling, and we did some modeling. That is, we basically did a couple of modeling like this, where we actually modeled a university, where we saw that we have got students, department teachers, courses, student courses, and then how they can be related with each other, what can be the primary keys and how can be the foreign keys for them. So today we will be starting into SQL, that is, we will be looking into practical implementation. So till now, whatever we're doing some theoretical knowledge about it. That is how exactly relational models are modeled and everything. Now we'll see how we can convert them into practical. So before we get started with the SQL, we need to talk a little bit about relational constraints as well. So when you are using a relational database management system, while we are trying to insert data, delete data, or we are trying to update new data, there are certain constraints that we need to follow. And based on these constraints, like whatever type of operation you are doing, based on what operation you're doing, some of these constraints may get violated. So when you're actually writing the code, or when you're writing the SQL program to insert the data, or we're trying to do some operation, you need to keep these constraints in mind. And based on these constraints, we need to change our coding, or we need to change the way we are trying to insert data and stuff. So the three main constraints that comes up in a relational DB, that's the relational constraints are, first we have is the domain constraint. Then we have is the key constraint, and then are the referential constraints. Now, what exactly do I mean by each one of them? So domain constraint means that we are trying to put some constraint on the format of the data that you are using. Like for example, like if we take the example of the student database that we had created, we said that as per the domain or as per the business rules, the student's roll number must always be an integer. It cannot be a string. So instead of an integer, if you now try to insert a string into it, that is going to violate the domain constraint. So especially when you're inserting data, updating data, you need to be careful about that. Next comes is the key constraint. So key constraint mostly talks about the primary key, and in case there are any unique keys that you have declared in your table definition, you need to take care of that. That is, you need to ensure that those keys which has been marked as primary key or as unique keys, those attributes must always be unique. So if roll number has been declared as a primary key, then there cannot be two students in the same table having the same roll number, because that is going to violate the key constraints. And like the key constraint, you have the referential constraint, which relates to the foreign keys that you have. So like, for example, if I take this example again of the university model that we had created. So we see that the student table references the department table based on the department ID. Now, let's say the way how a foreign constraint can get violated is, so if you're trying to insert a student record here in this particular table, and you give a department ID and that ID does not exist in this table, then that is a violation of a constraint. That is, you're trying to insert a department, or you're trying to assign the student to a department which is non-existent in nature. So this is known as a referential constraint. Now we look into each of the operations that you can do and what kind of constraints that you need to take care of. So if you're inserting data, you need to take care of all the three constraints. That is, if you're inserting a new data, you need to ensure you do not violate any domain rules that you have there. Like for example, as I said, like roll number is an integer. So when you are inserting the data, you need to insert a integer. You cannot insert a string there. Similarly, you've got the key constraint, which says that if you're trying to insert a data, then if you're trying to insert a new record, the primary key that you are inserting, that must be unique in nature. That record must not have been repeated in the table. And referential constraint, obviously, if you're trying to insert a data, you need to ensure that if there is a foreign key in your table, in your tuple, then that foreign key must exist in the referencing table, that the table that you're referencing. If you're doing update, almost the same thing. That is the domain constraint. Obviously, you need to take care of. That is, if you're updating a value and that new value is violating one of the format, one of the ranges, then that will cause violation of the domain constraint. Like for example, let's say we have a rule which says the age of a student can be between 5 to 30. So you cannot have students whose age is greater than 30. So if you have a domain rule like that and you are trying to update a value and you're updating the age of a student from, let's say, 30 to 31, then that is going to violate your domain constraint. So when you're updating the values, domain constraints are something that needs to be taken care of. Key constraints again comes into the picture, but generally it is not required, because key constraints mostly comes into picture when the primary key is getting updated. But ideal scenario says that you cannot update a primary key once the data has been inserted. If you want to change the primary key, that means you are changing the uniqueness of the record itself. So in that situation, you should delete that record and insert a new record. So that's why primary key updates generally doesn't happen. Hence, key constraints do not play an important role when you are trying to update a record. Then comes referential constraints, obviously get are of much importance when you're trying to update a record. If you're updating the foreign key, you need to ensure that the foreign key exists in the referential table. And when you're trying to delete, again, domain constraint doesn't matter because you're simply deleting the record, so no domain can be considered here. Key constraints again doesn't matter because you're deleting the record, so no uniqueness will be violated here. Referential constraint do matters, especially when some other table is referencing that record which you're trying to delete. Like again, if I go back to this example of department and student, so if you're trying to delete a department, then all the students who are referencing that particular department is going to get affected. So what is going to happen there? Like for example, let's say you're deleting this computer science department. So all the students, all the hundreds of students in the student table, which was referencing the department ID for CSE, they are all now going to get affected. So in this scenario, there are certain strategies that you can follow. One strategy would simply be that if you're deleting a department ID here, then all the references of the department must be deleted as well. That is known as cascade, and that is one of the most common ways of handling, deletion or handling referential integrity when you are doing deletions. Another can be like when you are deleting the department for a particular thing, do not delete the students. Instead, just remove the department ID by a null value. So that is also another strategy that you can follow. So based on your business rules, based on the software that you are trying to develop, you need to come up with a strategy to handle the referential constraint violation when you are trying to delete a record. Mostly cascade delete is what is preferred. Okay. Now that we talked about constraints, and constraints are actually really important because especially when you are designing the database and when you are and when you are trying to define the strategies as to how to update a record or how to delete a record and stuff like that. So constraints becomes really, really important, and you need to keep these constraints in mind when you are actually designing a database. Okay. Now we will come to SQL. So SQL. So before we go into SQL, we just need to understand one thing. See, right till now, whatever we are discussing, we're talking about a database management system, its modeling and everything. So these were very conceptual in nature. That is, we know that there is something called RDBMS, which is a database management system based on relations, and they represent the data and the data using relational models. But the question that obviously comes up is, how can we interact with the database, or how can we interact with such kind of a database? And it doesn't matter what kind of a database it is. It can be a NoSQL database. It can be something like a graph database or something like a document database that we saw in the initial video. So whatever type of data, no matter what type of DBMS you are using, there must be some way how users and applications can actually talk to the DBMS and get the data. Or in other ways, when you are trying to query the data, the DBMS must provide you with some mechanism using which you can interact with the data, or you can query the data or manipulate the data. So such a mechanism is known as query language. So database management system is providing with a language. It is kind of like a programming language, you can say, since we're talking to the computer, so you can term it as a programming language. So it's not essentially a programming language, it is a database language, but still you can think in terms of programming language. So database management system provides a language, a very specific language with its own syntax and everything, using which users can query the data which is stored in the database. This is known as a query language. And every type of data model, whether it is relational, non-relational in nature, whether it is key value pairs, whether it is tables, or whether it is graphical, it doesn't matter. Every kind of database has to support some sort of a language using which the users can query and manipulate the data. The manipulation part here is also important because users not only want to see what data is there, but there can be situations where users want to, add new data, update data, delete data, and stuff like that. So whatever language that the database management system has decided to provide, that must be allowed to manipulate the data as well. One of the commercial query languages, that is one of the most famous query languages that you have, is SQL. So SQL actually, so before we go into understanding what exactly SQL is, we just need to understand when you're talking about query languages, there are two types of languages that comes into the picture, or rather there are two ways how you can represent the queries. So first one is known as relational algebra. So relational algebra, it is nothing but it represents a set of relational operations for basic data retrieval. So relational algebra is a type of language, you can say, that it is also a part of a query language, you can say. It's a type of a query language which supports only basic operations, like getting like union of two sets, intersecting two sets, projecting a table, joining two table, intersecting two tables, Cartesian products between two sets, so stuff like that. So very simple procedural type of language for doing some basic data retrieval. Another type of query language is known as relational calculus. Now, relational calculus is non-procedural in nature. What is meant by this is, so a procedural language essentially not only tells what to do, but it will also tell you how to do it. Like for example, let's say I'm trying to get the first 10 records, or let's say I'm in the student table, and from the student table I'm trying to get the students who has received the highest marks. That is the top 5 students who has received the highest marks. Now, if you're using some sort of relational algebra type of query language, you will tell the system that, hey, I need the top 5 students who has received the highest marks, and will also tell the system, okay, this is how you should do. That first you are going to sort the records. After you have sorted the record, you are going to loop in and you are going to get the first 5 records. So you are going to tell each and every step to the database management system as to how to get the data. So that is what a procedural language is. But in a non-procedural language, you do not need to be specific. You simply tell, this is my requirement, I want this data, this is my query. Now, how the query is getting processed is not something that you need to be worried about. That is something which the database management system is automatically going to figure out, okay, this is what is needed. Based on the way my files are stored in the physical system, based on my clustering is done, based on the indexing is done, I'm going to be calculating and I'm going to be giving you back the data. So that is known as relational calculus. So any language, relational calculus is another type of language. Now, there is a term called relational complete. So relational complete is that any programming language or any database language which can express a query both in terms of relational algebra as well as in terms of relational calculus, you call it as relationally complete. Now, this is a very textbookish kind of definition that we have for a relational complete language. But in other terms, or in very simple terms, what a language which is relationally complete, when it is trying to express a query, it doesn't need to write a lot of if-else statements or a lot of for loops and everything. To give you an example, let's say you're using something like Java, and you're using Java to look into a table. So if you want to get all the records of all the records that are present in a table, the way you're going to be doing is you're going to be writing a for each loop, right? It is similar to getting all the records that is present in an array. Like if you want to iterate through an array in a programming language like Java, what you have to do is you have to write a for each loop. You have to go through each and every member that is present in the array and print that thing. But if that same problem comes up in SQL, and we tell SQL that, hey, you know what, give me all the records that is present in the table, it doesn't need to write any branching or any iterative statements. How it will do, we will going to take a look into it in a while. But relational complete languages, that is one of the basic features that you have. So now that we know that what is a query language and what are the various forms of a query language, we can take a look into SQL. So SQL, as we initially saw, it is one of the most popular query languages that you have. And a lot of people believe that because a language like SQL exists, this is the reason why relational databases are so popular. Like in any other kind of databases that we have, although it's a very controversial statement, but any other kind of databases that you have, the query language which is supported by the database management system is not as extensive as SQL is. So, and SQL is something which has been battle tested over the years. It has been refined, its standards has been improved and everything. So today SQL is a battle hardened query language for relational database management systems. And that's one of the reasons why, relational databases are still relevant even after so many years. Another feature of SQL is that it is declarative in nature. Declarative means it is non-procedural in nature, and we just understood what is non-procedural in nature. Using SQL, you tell the DBMS what you need to do, you don't tell it how you do. And SQL is obviously relationally complete. Some of the features of SQL, so it contains DDL, that is data definition languages. So data definition languages means that you can actually set up commands which can allow you to create tables, delete tables, modify tables, create views. We'll come into what exactly views are sometime later. But SQL gives you a set of commands using which you can manipulate, like create table, delete table, alter table, and stuff like that. Then comes this DML, which is data modification language. So data definition means it is the how the data is going to be stored in table. Data modification means once the data is ready, how you can post queries to the data to get results, how you can insert things into the insert records into the table and stuff like that. Then comes embedded SQL. Embedded SQL essentially means that you can embed SQL or like other programming languages like C, C#, Java. They can actually use SQL. So you can actually embed SQL in a web application or in an application. That's another feature of SQL. Triggers means that when you are, let's say, inserting a record or you are deleting a record, you can actually do some work based on such events. So triggers essentially means that when you're trying to do some modification in the in your database, you can get a hold of that modification event that has happened, and based on that, you can do some work on it. Transaction management, we discussed a little bit about transaction. So transaction means that it ensures that your database always remains in a consistent state. So that is something which you can support using SQL. Indexes also, we will not go into details now because we have a later video. We'll cover what exactly indexes are. But indexes are for speeding up your query processing. Now, one thing about SQL is that SQL is actually a standard. That is so SQL is kind of you can think it to be a specific set of rules that someone has said, okay, if you want to a query relational database, then you can follow a standard, and the standard is SQL, where they say, okay, these are the operations that must be allowed, these are the specifications that must be allowed, and stuff like that. So this being a standard, there are many vendors who have actually taken that standard, they have followed that standard, and then they have created their own database management system or own on top of it. So historically speaking, it was originally from IBM that the concept of something like SQL came. So they were experimenting with a database called System R, and they were looking for what kind of language can be used to query a database like that. So that is where the idea of SQL came. And then after a few years later, after with ANSI and ISO, that is American National Standard Institute and International Standards Organization, they kind of collaborated with each other. And in 1986, we had the first official version of SQL. Then a lot of other SQL versions have come. Like 99 of SQL 3 had come, which is one of the most used version out there. And then there are products. So like one product called MySQL was developed, which was developed by a company called MySQL AB. Currently, MySQL AB is a company which was acquired by Sun Microsystem, and then Sun Microsystem in 2008 got acquired by Oracle. So currently, MySQL is owned by Oracle. So MySQL is a very lightweight database that we have, which is a lightweight database that we have, which also uses SQL. Then you've got the Oracle database, one of the most popular and the famous databases that you have in the world as of today. SQL Server, again, very popular. It was developed and owned by Microsoft. SQLite, another thing, it is very small and lightweight in nature. And for starting purposes, a lot of people actually prefer using SQLite. And apparently, it is also one of the most downloaded databases that you have. So this is about like a very theoretical knowledge of SQL. So before we go into some demonstrations and practical, I would like to take a pause and see whether there are any questions posed on the YouTube live chat. Okay, I do not see any questions posted on the live chat, so that's fine. One quick reminder, if you do have any questions, if you do have any queries or doubts, please feel free to post it on the live chat to the students who are listening to the course here. And in case you have any, or you can, if you have or if you're not in live, if you're watching the video later, you can also post it in the comment section. And if you're registered for the course, you can sign up for the doubt clearance session where we can talk to you about your doubts and questions. All right. Next, we'll start off with a very practical example actually. So practical example in the sense what I'll show you, plan to show you is that we just talked about SQL Server, right? Something which was developed by Microsoft. So what you're going to be actually seeing is a very practical example of it, that how exactly, a SQL server is kind of set up, and in a production scenario, you can actually use that SQL server to do a lot of operations and stuff like that. So in the rest of the demonstrations that we will be showing, probably will not be using something like a Microsoft SQL Server, because that's a very commercial product. We will probably be using the SQL Lite, and Newton School's Playground has support for it. So a lot of our coding, we will be actually doing it in the Newton School site directly. But for initially, just to give people a taste of how exactly SQL Server works in a production environment, I'll just be showing some of the demonstrations out there. So this is an Azure portal. So Azure is nothing but one of the cloud offerings from Microsoft. So like what exactly is a cloud and everything, again, it is way beyond the scope of this video. But just to understand what you mean by a cloud. So cloud computing means that a vendor like Microsoft or Amazon's AWS or Google's GCP, they will offer you some products which are hosted into their servers, but you can lease that. You can lease that and you can use it as if it belongs to you. And obviously there is a payment structure where you need to pay them for the things. And when you don't need it, you can just delete those resources and you won't be billed for that. So that is actually way 50,000 feet above what exactly cloud computing is. So what I have done here is, in my Azure portal, I have created a SQL server. Okay. So what you're seeing here, this one is actually a SQL server. Rather, this is not a SQL server actually. Yeah, this is actually the SQL server that I have created. So SQL server is nothing but you can think of a computer VM or a server which is sitting at some location. Currently, it is sitting in the data center in, I think it's a location in Southeast Asia. So in one of the Microsoft data centers in Southeast Asia, this is where the server has been created. So I have hosted a server. I have kind of rented a server there, leased a server there. And in that server, I have created a SQL server. Okay. Now, in that SQL server, I can create multiple databases. So I have created a database called DemoDB. So, and I have created some tables here. So I'm not going to show you exactly how these tables and everything is created. So this is actually a physical database which is created. And you can use this database now to query into this database, write programs on top of this database and stuff like that. So again, I'm not showing exactly as to how to create a database in Azure. There are a lot of documentation available. Extensive documentation is provided by the Azure team, which you can actually take a look into exactly how to create a database. This is just for a demonstration purpose. I'm showing you a database has been created here. Now the next question that comes up here is this dashboard that I'm seeing. This dashboard simply gives me some options to check, okay, how much of my database has been utilized, how much of the space here, like only 28 MB of the database has been used. And total there, I can store up to 32 GB of data here, but I'm only storing, I think 28 MB of data. And then I can see stuff like, that I can use a Power BI dashboard on top of it. I can do some geo-replication and stuff like that. But anyway, the point here is that you cannot actually see what is the data stored here. We can see how much of data is getting utilized and how much of data is getting stored and everything. But I cannot actually, see the data. I cannot visualize the data here. So for that, there are multiple tools which have been created. Some tools are open source. Some of the tools have been created by Microsoft. So we have an open source Microsoft tool called Azure Data Studio. Yeah, this is the Azure Data Studio. This is exactly how it looks like. So in Azure Data Studio, what you can do is you can connect to a database. So the database which I just showed you, like the database which was just created, I can actually, using some password mechanism and everything, I can connect to the database. Okay. So let me just show you how we can connect to a database in Azure Data Studio. So if you have opened the Azure Data Studio, you can download this. This is free of cost. It's not a it's not a priced software. This is an open source software. Anyone can use it. So what I'm going to be doing is I will first create a new connection. So for creating a connection, what I will do here is I'll click here, new connection. Then I need to give some details like what is the server name and stuff like that. So if I do go back into my database here, you can see the name of the server is actually demodb-like class. And the name of the database is demo-db. So that is what it needs, that what is the server name. So I can give the server name probably. So server name needs to be given in a particular format, which is like name of the server.database.windows.net. Then how do I log into the database? I'm going to log in using my username and password. So when I created a database, I gave it a username and I also gave it a password. You folks won't be able to see the password because that's going to be hidden. and then the name of the database. So name of the database that we saw was demo_db. Yeah, that is done. Let me click on connect. So now it is going to query and it's going to try to connect. And here you see the database, I think, is already connected. Yeah, see the database has been connected, and out of the box, what Azure Data Studio gives me is it tells you what are all the tables which are present in this particular database, how they look like, and this normal stuff like that. So let me write up some simple queries actually to understand how exactly this looks like. So here we have put a database called customer. So again, we will be going into each of these commands in details in some time. I just wanted to give you guys a taste of how exactly things look like. So if I run this, okay, sorry, my bad. I run this here. So we have got a customer table here, and all I'm doing is I'll go and explain each one of this in details a little bit later, or probably in the next video. But what I'm essentially doing here is I am simply telling SQL, hey, there is a table called sales_customer. Just show me the top 10 values and show me all the attributes. That's the reason I'm using the star here. So you can see I've got the customer table, which I've got customer ID, some name style, title of the customer like Mr., Miss, or Mrs., first name, middle name, last name, whether you have got a suffix, which company do you work for, who is the salesperson, that is, who is the sales guy that worked with this particular customer, what is the email ID of that customer, phone number of that customer, password and password salt. So this one again, like you don't have to worry about it. To hash and salt is actually about like, so if you customer is trying to log into the system, they need to give a username and a password, right? So the password, you cannot directly store the password, like you cannot store the naked password here because that's a security constraint. If anyone gets if anyone gets your database, they can see your password. That's the reason why a password is hashed and then it is stored, and there is a salt which is added to the password as well. I'll not explain this in details. This is way beyond the scope of whatever we're trying to understand here. There's a rogue bit, and the modified date means when was the last time this database was modified. And by the way, the database which I'm showing here, this is known as the Adventure DB. It's a very famous sample database which is available. So if you're trying to do SQL and you want to learn about how database and things work and stuff like that, and you want to do some practice work, this database, Adventure LDDB database, is one of the most famous database. You can search for this database, people who are interested in understanding what are the tables and everything that is present in this database. So this is a very sample database that I have created here. There are other tables here as well. So I think probably I'll do something like, again, top 10. Apart from, I think there's a table called product as well. I'll do that table. It's just product here. My bad, that typo. Yeah, so these are all the products which are available here. So like this, like again, I mean, going into the details of this particular databases, we have to do it. But this is just for a demonstration purpose to show you, like, if you want to connect with a database which is actually hosted on cloud and not something which is in a local system or you're trying to do just normal testing, this is one of the ways how you can do that. Right. I will go back to the slides for a minute, and then again we will start with the Newton School ID. Before that, once more, just to take a small look into whether there are any questions about so far. No questions again. All right. Going back. So okay, before we actually start creating tables and everything, we just want to take a look into the data types which are available in SQL. Like since we are creating tables, then each attribute that we are creating, they need to have some sort of a data type, right? So I just want to show you what are the data types that you can use. Now, this is not an exhaustive list that you are seeing here. There are multiple other data types which are available in SQL, and based on the type of SQL you're using, like are you using SQLite, MySQL, or SQL Server, or Oracle, these data types might differ a little bit. But these are some of the most basic data types which are almost supported in almost all of the databases that we saw. Anything which supports SQL must support kind of these things. First one is varchar. Varchar means a variable in string that is as close to a string that you can get. Int, it's a medium integer. The limitation is given there. Big int, it is a big integer. So if you're coming from a world of Java and programming languages, int and big int can be represented as int and long that you have in Java. So you can drop parallels to that. Double, obviously, if you want to represent a decimal precision number. Date time, if you want to store a date time. There are a lot of other data types. So if you're interested, do go search for what type of SQL data types you have, and based on what database you are using, the name of the databases, name of the data types, and the syntaxes might differ a little bit. Now some command, basic command. So first thing that we'll be trying to do when you are in the SQL is we need to create a table. That's the very first thing. So whatever databases we're creating, it doesn't matter. And probably since yesterday we did this university model, probably we'll try to follow this model only. That is, so the first table that we had modeled was a student table. So if you have to create a student table, how do you do it? So we need to have a command, right? And we said that SQL is a command which will allow you to do DDL as well as DBMS. DDL means data definition language. That is, it will allow you to define the data, define the tables as well. So SQL should have commands to create a table. So this is the way you create a table, create table, give the table name, and then all the column names and stuff that you have. Okay. Why don't you just see theory? Probably we'll go ahead and just see a live demo, a live demonstration for that. So I need to open my Newton School site. Yeah. So in Newton School, if you want to do some coding, what you need to do is you need to go to the playground. That is after you're registered, you need to go into the playground. And in playground, you can create this kind of editors, or you can create your own. You can call this as projects as well. So when you're creating a playground, you have to first you have to give a name. So I'll just say, let's say SQL basics. Sorry. Description and title, those are things that you can give as you want. So this kind of a screen comes up. So where you can see that this is the code. So this is where you're actually going to be writing the programming language, whatever code you're using. In the right corner, you're going to be seeing what you could give inputs, custom inputs to the code that you're writing, and then you have got the standard output as well, where you can see what is the data that is getting outputted. So I'll just increase the screen a little bit. And one more thing is that when you are when you're trying to write the code, you can actually choose what kind of code you want to write in. So this is where you can see that Newton School supports a lot of such programming languages. Like if you want to do C programming, C# programming, C++, Java, Fortran, Erlang, a lot of support code is supported. We are interested mainly into SQL, and it is using SQLite. This is a version, and the version doesn't matter because we'll not be doing any version specific code. So let me choose it. So we are into SQLite now. So now whatever code we write, we can it will be executed. It will be executed in SQL. So let's see. That first thing that we said is we're going to be creating a table, right? And the table that we're creating is a student table, which has got a roll number, name, age, gender, address, and a department ID. So for now, let us forget about the department ID because department ID is nothing but a foreign key. So we will not look into it right away. So if you want to create a table, so your commands should be something like this: create table, followed by the name of the table. So name of the table is, let's say, student. Now there are a lot of documentations and everything which talks about conventions as to how you should name your tables and everything. So the convention which I follow, and that's a general convention which a lot of people follow, is your table name should not be plural. So although the student table holds a number of students, so you might be you may think that maybe I should name the table as a plural, but ideally it is not a scenario, that it's not a convention that we follow in SQL Server generally, and we do not try to name a table as plural. We name it as singular itself. So I've got this create table, I've got student, and now what we have to do is in the brackets we need to give what are the attribute names that this student table has, and what will be the data type of it. The first thing that we had was the roll number. Okay, so if you come here, you remember this is the column name, so we have to give the roll number. So here is the roll number, and the roll number is of type, let's say, integer. So how do we do that? Int, because we just saw that int is one of the data types, comma. Next thing that we need to give is, let's say, the student name. Student name, and student name is a string, so string is represented as varchar. Now in varchar, once you've given, you need to tell that how big the student name can be. That is how many characters are allowed there. So I give something like 255. And one thing to note here is this thing, varchar 255. This is also domain constraint. It tells you that if you're trying to insert a student, if you're trying to add a student name to a particular student, that string cannot have more than 255 characters. That is what is meant by varchar 255. That's a domain constraint that has come up. Then let's say I'll give you the address. So address also I'm going to give varchar. Addresses can be really big sometimes, so probably I'll give 500. I'll allow 500 out there. Then is the gender. So gender is also MF or something like that. So if you give that, so I'll make it varchar 1, which means that there's only one character allowed. It will either be M, F, or U if you don't want to disclose it. Age is again integer, so no problem there. And probably we will enter one more thing here called CGPA. All right, double. So CGPA is nothing but the marks that the particular student has got. So this does it. Now if I just simply run it, it will run, although but there is nothing to actually output, so it's not going to give you any output here because all you have done is just created a table. But this is one of the commands that we have done. We have actually now created a table. So table is created somewhere in your SQLite, in the SQL server, their table gets created. Now the next logical question that obviously comes up with, how am I going to insert data into this table? So for inserting data into the table, this is the syntax that we follow. Insert into, give the table name, and then all the column names that we are following, followed by the values. Now the reason why you need to give the column name is because the values which you are giving, they may not be in the order. That is, they may not be in the order in which I had declared these attributes. They may be in a different order altogether. That's the reason why when you're inserting the values, we need to tell that for which column represents to which value here. So whatever column, the first column name that you tell here, that corresponds to the value that you're inserting here. The third column name that you insert here, that corresponds to the third value that you are inserting here. All right. So let's go ahead and insert some data here. So insert into name of the table student. Now I need to give the column names here. I'll give them in a minute. And then I need to insert what are the values for them. And in the values, I need to insert exact value which is corresponding to the columns here. So first, let's say I'll be giving roll number. So roll number of the student, let us make it as 1. I need to give a name of the student. So name of the student, let's say I will give something as sorry, again my fault. Here I have to give the column name. So the column name is student name, and this is where I need to insert the actual value. Then comes the address. So address again, like so for the sake of just saving time, I'm giving address as NF, but you can give whatever address you want. There is no limitation or anything like that. After the address is given, next we need to give the gender. Gender is again a 1-character string. So this is a female that we're talking about. The age, let's say something around 22. Next is the CGPA. Let's assume the CGPA is something in the range of 9.1. All right, sorry, 9.1, whatever. So that's done. And if I run this, again, nothing is actually going to happen here because all you have done is you have created a table and you have inserted data into it. The next thing that comes up is, how can I see the data? Okay, so this is where we will be introduced into something known as select. So select command, now this is, we will be seeing a lot of select command. So basically every kind of query that we write, or most of the queries that we write, whenever we are trying to retrieve any data, select is the command which comes into picture, or select command is the one which you use. So select command is used to actually project the information that is stored into the table to you. So if you say select, and then you need to give the column names, that is which are the column names which I'm interested of. If we want all the columns, I just give a star, and then from which table I want to see the data. So let's just see it in an example, it will be better. So I say select star from name of the table is student. So what this is going to do is, it will check, okay, you know what, I am trying to access the table here, table name student. And when it is going to look into the data that is present in the student, and it will see, okay, from the student table, whatever information I am present, what are the information that I should project, or what are the information that I should print or return back, whatever you can think of any other terms. So this is where it is going to go here. Star means get all the information that is present. Like irrespective of what columns are there, what attributes are there, get all the information that is present. So select star from student essentially means you are going to get all the data that is present in the student table. Let me run this. Yeah. There it is. So look at this. So we had inserted the roll number, the student name, the student address, we had given it as NA, the student gender, which was F, the student age, which was 22, and the student CGPA, which is 9.1. So it is going into the student table, looking for all the data, taking the data and giving it back to you. Now let's make it a little more fun, because just one student doesn't look good. So we'll insert quite a lot of students. So let's say I'm going to insert a second student called Ryamishra. Again, I don't want to give this age, probably let me insert the age, another my pointer, that's great. Let's enter another student here. Again, I don't want to give an address here, but it's a male, age is 29, CGPA is, let's say, 9.48. Let's insert a few more. Male, age let's say 35, and we give CGPA of 0.8. Then I give something like, let's say, male, age probably somewhere around 74, and give CGPA of 8.8. So now what you've done is we have inserted 5 records into the table. So now when I try to do a select start from student, that is when I'm trying to select a few values or project some values from the student table has 5 records. So ideally what it should do? It should give you 5 lines. So let me run this. There it is. All the information that is present in the table in the student table, all that information is now getting projected into the screen. So you can work with all the information that is present here. Now again, like, so if we now track back a little bit and we try, and there was a statement that we had made initially when this video started, that is SQL is declarative in nature and is relationally complete. And we say that in relationally complete languages, you do not have to write expensive branches or iterative loops to give you back data. We can do it in a single line. So this is exactly what is happening. If this kind of an information was actually present in Java, like let's say you are trying to present this information in an array of objects and you want to print all the array of objects, what do you have to do? You have to for loop into all the objects that you have, take each object from the array and then print it. So you have to do an iterative kind of programming. But here, if you see the kind in SQL, the program that we wrote, we just wrote a single line. That's all that we wrote. We just wrote a single line, and from that single line, it automatically gave us back the data. So that is one example of what we said that we're going to be doing relationally complete. Okay. So now again, I'll just pause for a few minutes to check whether there is any questions that has been posted on the live chat. Nope, nothing. That's fine. Okay, I shall continue. Now, the next things that we are going to be doing is we will actually look into the variation type of projections that we're going to vary the projection that we have got. That is the first select thing that we have got. We're going to vary something and we're going to see how we can get some information that we need and everything. So let's say what I'm going to doing here is that, hey, I'm getting all the information back. Right? That is, I'm getting the roll number, name, address, gender, age, CGP, and everything. Let's say I don't need all that information. That is, all that information is not really needed. All I want from SQL is to give me the name of the student, the marks of the student, and what is the age of the student. That's all I need. I don't need all this expensive information like roll number, address, and everything. That is not something that I'm interested in. So if I do something like that, so this is where the column name comes handy. So right now what I've done is I've given select star. Star means get me everything that you have, all the columns that you have, project all the columns. But now I'm saying do not project all the columns, project only the columns which I need. So what are the columns I need? I need student name. Second thing that I need, let's say their gender, and I need their age and their CGPA. I don't need their address and the roll number, let's say. Or probably let's say I don't need their age also. I just need their gender and I need their CGPA. So if I run this, now look at the output. The output has got a shortened. That is, instead of giving me the roll number, address, and every other age and every other information, I'm only getting those information which I need. I need the name, gender, and the CGPA. Here again, if we track back to one of the initial videos which we had created, where we were talking about that depending upon what kind of customers or what kind of users are coming into your system, you can create a separate type of view for them. That is, they may only get to see that information that they want to see. They don't have to be shown all the other information. So this is one of the ways how SQL does it. That is, based on who's coming into the system, it can actually alter the query. That it can say, okay, you know what? Not everyone needs to see the age. They only need to see the gender and the CGPA. That is good enough. The age might be seen only by the administrator for some administration purposes or stuff like that. Not everyone needs to see the age. Not everyone needs to see the roll number and stuff like that. So this is how you do it. You actually control which are the attributes that you're interested in, and you just give that attribute. Okay. Now here till now, whatever SQL queries we are seeing, we are kind of projecting, or we're kind of getting everything that is present there. Like select the student name, gender, CGPA, but I'm getting all the values which are present in the student table. Right now it is only 5, but I'm getting all the 5 values that is present in the student table. What if I want to give some conditions? Conditions in the sense I want to give something like, say, okay, you know what, I want to see only the female students which are present. I don't want to see the male students which are present. So in that situation, what we have to do is we have to write a condition. So for writing conditions is where the where clause comes into the picture. So till now we did the select clause. Select clause is used to tell that, hey, what are the attributes that I'm going to be selecting, that I'm going to be rejecting. From clause tells you from which table I'm taking the data, and where tells you that from the table that I'm getting the data, do I need all the information or can I just strike down some information? So in the where, whatever you're writing after the where clause, the statement that you're writing, that needs to be a conditional statement. Conditional statement in the sense that whatever the statement is, that must return like a Boolean value and it must give you like a true or false. So here, what are we looking for? We're looking for all the students, all the female students. So how do I know whether a student is male or female? Based on the gender. The gender value for a female student is going to be F, and for a male student, it is going to be M. So here I can write the simple query where gender is equal to, F. So this means what? That from the student table, only get those records whose gender value is F. If the gender value is not, if the gender value is F, only get those records. And after you have got those records, what are the column names you will show? You will show student name, gender, and only CGPA. So here, if you look into the data that we have inserted, we can see only Manju Verma and Riya Mishra are female, everyone else is male. So if I do run this query, ideally I should be only getting the top two records. Yeah, that's it. So this is how simple conditions work. So when you're selecting data, when you're projecting data in SQL, if you want to give conditions, this is a very simple way of how we can do it. Okay. We will look into a little bit of a little more complicated condition here. So let's say that now I want to get those students who have been scoring more than 9 pointers. Okay. So as per our data, it is only the first two students who have been scoring more than 9 pointers. So I want to see that data. So this condition we gave us where gender equal to F. Now this condition is not needed because I want a different kind of condition. So here in this condition, what is the so what I'm going to be giving? I need where the value of CGPA is greater than 9.0. That is a simple condition which I can give. So now if I go ahead and run this, there it is. These are the students, Manju Verma, Riya Mishra, and Pratik B. These are the students who are getting more than 9.0. So that's the reason I'm getting back their result. Now let's make this condition a little more interesting. When I say I not only need to get those students who are getting more than 9, but I also need to go get those students, or rather I need to know the female students who are scoring 9.0. So here there are two conditions. First condition is any student who is getting more than 9.0. That's the first condition. The second condition is among the students who are getting 9.1, I only need to further filter it by only those students who are female in nature, who are female. So this is where I can do something like and gender is equal to F. So if I do this, there it is. Because that's exactly what I wanted, right? That is, I want those students whose CGPA is greater than 9 and their gender is F. So this will give me all the female students who are getting more than 9.0. So this is the result that I get. Now let me just cut down the gender for a moment because anyway, let me show this data. Okay. Now let's say I am saying, so okay, one thing that you can give, okay, let me cut down the where statement also so that it is better to explain. I query this, I get back all the students. Now one thing you're seeing that the students are always coming in a particular order. That is on order is like first Manju, then Bia, and then Pratik B, then Akhil. And so the question should be in which order is actually SQL giving me the data. That is, there should be some order that SQL is storing the data in, and then only based on that order it is giving it back, right? So the question is that in which order is it actually giving the data back in? So the answer to that is the roll number here. But it is not always going to be the roll number. It can be any value here. Here, since roll number is the first thing that we are given, that's the reason why it is storing the data in the roll number values. But if it, in case of roll number, if it given some other values, it could have been doing it in some other values as well. And since we have also inserted the data in this order, that's the reason why it is getting stored in this order. But when you're inserting records, but when you're querying for records, you may not want it, right? Like let's say you are giving, like let's say since you've inserted the order in increasing order of the roll number, that's the reason why they have been stored that way. like student 1, student 2, student 3, student 4, like since you have inserted one by one, that's the reason why they're getting stored that way. But that may not be the case, right? Let's say I want to get all the students in the order of the marks that they have received. That is, I want to know all the students who have received the, that is, whoever has received the CGPA highest, that name should come first and the second name should come. So this is where order by comes into picture. So I've got another clause called order by now. So we learned about select clause, from clause, now order by clause. In order by clause, I need to tell that when I'm getting the data, the data should be ordered, or data should be sorted by which attribute. So here I'm giving ordered by CGPA, that's all. Now if I run this, what you will see, that it got ordered by CGPA. Now one thing is that when you say ordered by, it automatically by default it takes ascending order. So that's why the lowest CGPA student came first, followed by the highest CGPA student. Sorry, at the last was the highest CGPA student. But if you want it in the reverse order, that is, I don't want to sort it in ascending order, rather I want to sort it in descending order. So if I want to do something like the keyword is DESC. So order by CGPA space DESC. This means order the data by CGPA in descending order. Let me run this. Good, done. So now the student with the highest CGPA comes first, and then the student with the lowest CGPA comes at the last. Now another query may also come up which says, okay, you know what? I don't want to say check all the students. All I need to know is I need to know who are the top 3 students who are getting the highest CGPA. That is, see, like Pratik B, Riyamesh, and Manjubi, I just want to know this information. I don't want to know the information of students who have scored a lower than means who are not in the top 3. I want to know only the top 3 students. But when I'm saying something like select student name, like select from order by, there is no way how I'm saying how many records you should give him. I'm just telling you, give me the records. So this is where another in SQL, since you're doing SQLite, another command comes into the picture, another clause comes into the picture, which is known as limit. So limit will tell you that whatever you're trying to get, whatever you're trying to project, whatever in whichever order and whatever you're trying to get, how many you should show. And it's your limit 3. That means it is going to show only the top 3. So now if I do this and run, what do we see? There it is. It's showing only the top 3. Now, one thing to remember is since we're doing SQLite here, that is why the command is something like limit 3. But if you're into something like SQL Server, the command is, it doesn't give limit 3, it is like select top 3, like that. But however, since we're not doing my SQL Server here, we are only doing, we are showing that in, all the demonstrations and everything in SQLite. That's the reason it should be like this. Okay. So that is about the basics of SQL. We saw like how to, create tables, how to insert data into the tables, and how to select students and into it. So from the next video onwards, we will be going much deeper into it. We will also see that how you can declare primary keys, how you can declare foreign keys, how you can join multiple tables based on their foreign keys and do some query operations and everything. So we will do a lot more complicated queries in the next few videos. So stay tuned. Before I close the class for the day, probably we'll just take a look into whether there are any questions in the live chat. Line number 22, there is a, okay, Vinit, I'm not sure exactly what your question is. Probably you can just explain that a bit, because I'm not getting the repeat question that you're getting. Where is the repeat that is happening? Is there a repetition that I've done in the class? It doesn't look like so. All right, Vinita, probably you can post it as a comment there in case you're like what exactly is your particular question. Okay. I don't think there are any other questions, so I think we can call it a day. So once again, thank you everyone who was able to join this session. I hope that you learned something from this session. And if you have any further questions, if you're registered for the course, you can do it in the doubt clearance session, or if you're in YouTube directly, you can post it as a comment, and someone is going to get back to you. Thank you again. And for the next series of videos, next few videos, we will be doing all the SQL queries. We will be seeing what are the practical scenarios of what kind of queries we can have, some complications into them. Then we can design some databases, add some references and foreign keys and stuff like that. So these are the things that we'll be doing in the next few videos. And then we will be looking into some advanced concepts like schema refining, normalization, indexing, and stuff like that. So thanks again. Thank you, everyone. Have a great day.